Okay, so based off of the directions here, where we have cosine of 2x, the amplitude doesn't actually change. Oh wait, that's sine. Okay, so this is cosine. But the fact that we have 2x right here, that's saying that they're squeezing the period down. So instead of being one cycle being 2 pi, one cycle is actually pi. So what are we looking at is from pi over 4 to pi over 2, like right over here. So right, this value is pi over 2. And where's the other value? Pi over 4 is half of pi over 2, so it's right here. And y equals 0 is this area, is all we're looking for. Now, if I were doing this, okay, so that pi over 4 is your lower bound, your pi over 2 is your upper bound, and it's 0 as your upper function, y equals 0. That's a x-axis, in case you didn't know, minus cosine of 2x dx. But some of you might be sitting there and say, what's the point of writing 0? Is you actually don't need to write that out. But that's why it's a negative there. So if you do the antiderivative of this, some people would do u substitution. I wouldn't, just because I know the antiderivative of negative cosine is negative sine. But then I would think about, this is really the chain rule, because if you did the derivative of negative sine, you would get negative cosine, but then you'd have to take the derivative of 2x, which is 2. So you can see that I'm missing that. So you can fix that by putting 1/2 in front. And that's from pi over 4 to pi over 2. So then from here, you can actually plug that in. Negative 1/2 sine of 2 times pi over 2. Okay, so things will cancel. And then minus negative 1/2 sine of 2 pi over 4. Well, you can see that that would simplify to be pi over 2. So what is sine of each of these? Well, sine of pi is the y coordinate, which is the ordered pair 0. I went to pi, by the way. So this piece is 0. So really what we're left with is negative 1/2 times 0 is 0, plus this value for sine of pi over 2. We want the y coordinate is 1. So this piece is 1. 1/2 times 1 is 1/2. That's your answer, 1/2.